So skill 10 had us performing arithmetic on vectors including the dot product. So the two integers I chose was a equals 12 and b equals 15, and then c, the angle I chose for that would be 30 degrees, and d would be 120 degrees. Therefore, that made this angle here 60 degrees. Now the first step was to actually calculate the coordinates for the vector before you could do parts A through C. So essentially, for calculating the components of a vector, the x-coordinate would be the magnitude times the cosine of the angle, and the y-coordinate would be the magnitude times the sine of that angle. So for A with C, I did 12 times the cosine of pi over 6, which is 30 degrees, comma, 12 times the sine of pi over 6. And then for V, it would be 15, because that's the magnitude, times the cosine of 2 pi over 3, comma, 15 times the sine of 2 pi over 3. Now you could have also solved for this using the law of sines. However, this is another method to do to get like the exact forms. With the law of sines, you would get like approximations, but they would end up equaling each other. So now for part A, it was vector addition. So the first thing I did was add the x-coordinates to get the new x-coordinate, and then add the y-coordinates to get the new y-coordinate. So I got 2.89, 18.99. So that's where the vector is when you add the two vectors. Now for the magnitude, I kind of imagined a new triangle would be created, and then this would be, this length of the triangle, and then the y-coordinate would be this length of the triangle, and I basically used the Pythagorean theorem to solve for the length of the magnitude. And I got 19.21. Now for the direction, I used the arctangent to get the degrees, and then at the very end, so like this is again showing, using the inverse of tan, etc., etc., and I got the degrees. However, I added 30 degrees at the very end because you still have to account for the argument angle. So for this one, it would be the 30 degrees. And so that's how you'd get the direction. Now moving on to the back, for part B, it was v minus u. So again, I subtracted the coordinates with each other. This is again the exact form, the approximation form, and I got negative 17.89, 6.99. Now again, for the magnitude, I kind of imagined a triangle would be created, and I used the Pythagorean theorem to get the magnitude. And I actually got the same magnitude, which was 19.21. Now for the direction, again I used tangent, and I got the degrees, and I, of course, accounted for the argument angle. Now, part C was different because it was the dot product. So this was the vector u times vector v. So here, to calculate the new vector, you'd basically multiply the x-coordinate with the second x-coordinate, and then you'd multiply the two y-coordinates together. So essentially, I got the same answer, except one was negative and then one was positive. So they were opposites. Therefore, when you added them together, you would get 0. So for part C, the dot product of this problem would be 0. And that's skill 10. Ta-da!